I'm Tom Korn, Senior Vice President of Security Products at VMware. Today I want to talk to you about VMware AppDefense, which is an exciting new solution we're just introducing into the market that's focused on protecting applications that are running on virtualized and cloud environments. When you consider most of the security controls that you have in your environment, the vast majority of them are here. They're installed onto network security products, or onto the compute stack. But ultimately, what we're really trying to protect are applications. And so a lot of the work that we've been doing with our solutions is to help align and focus security ultimately on what you're trying to protect, applications. And a big part of this is how do we create least privileged environments around these applications. Now with NSX, our network virtualization platform, and the introduction of microsegmentation, we created least privilege from a network perspective. With AppDefense, we're creating least privilege on the compute stack. And what does that mean? When you look at the compute stack and you look at an application, really what you end up seeing is a series of machines, but inside those machines, what you see is a series of processes that are running. Those processes are running on top of operating systems. Some of these processes are communicating out, or some of these processes are listening in. When you're attacked at the application level, malware or other types of attacks, what happens is very often they're attacking the operating system, or they're introducing new processes, or they're manipulating processes so that they're communicating to other things, either to spread through the environment and move laterally, or to connect and communicate to command and control servers. And what we've done as an industry is introduce a series of sort of endpoint security products, typically installed as agents or kernel drivers onto those machines, that are focused and very innovative at finding and identifying bad behavior, malicious activity. And it does this through a whole variety of techniques. But the challenge that we've been facing as an industry is that it's just the threats are constantly changing. It's impossible to keep up. We're constantly chasing this evolving threat landscape. The second problem we have is noise and complexity. We get so many alerts and information overload in our environments that we simply don't have the people or the manpower to be able to deal with it. And the same is true of the third issue, which is just how manual a lot of the response process tends to be as we identify a serious threat in our environment, and we have to figure out how do we remediate through this environment. So the question is, can we, just like we did on the network, can we leverage virtualization to create a least privileged environment here and really address some of these fundamental problems? And the answer is yes, we can. And what we're really doing is leveraging the fact that under these machines, in between these machines and the physical infrastructure, we already have this virtualization layer that has three really compelling, unique properties. And one of them has to do with application visibility. It's a wonderful place to be able to see not only what's running, but also what was provisioned there in the first place, which is a very unique perspective to understand what was supposed to be there rather than what is. The second unique property is isolation. The fact that with the virtualization layer, we have this separate trust domain from which we can do these kinds of operations from a protected environment. The third unique property is automation. The fact that with a software-defined infrastructure, we have a fully programmable, automatable infrastructure. It's software. And that means we can use it to our own ends in security to respond, to quarantine, to re-image a machine, to suspend a machine, to block communications. Suddenly those things are very possible to orchestrate and to automate response. And that's exactly what we took advantage of when we built AppDefense. So taking a look at how this works, starting with AppDefense, the first piece we really work on is we automate the process of understanding intended state. What were things supposed to be? How does this work? Well, what we created was this intended state engine that hooks directly into vCenter to understand the complete inventory of all the machines that are inside that environment. And at that stage, we have a complete picture, but we really don't understand what was the purpose behind those machines. Next, it hooks into your infrastructure provisioning systems. Puppet, Chef, vRealize Automate. And that starts to tell us, oh, gee, that machine was really a database server, part of the database tier of this mortgage system that we've created, and it was supposed to be running Windows 2012. Now we start to get the sense of what an application really is and starting to see the environment through the application. But next, we start to hook in to all of the application automation frameworks. Things like Ansible, Maven, Jenkins. Suddenly we see the packages that have been installed on those machines. So we start to see, oh, these are the processes and the kinds of communication patterns we're supposed to see inside those. Lastly, we actually trigger a component of ours on ESX in the hypervisor to start observing the application while it's running. This could be in the staging or in production. And we kick off a machine learning mode, which starts to observe, are there any things that we didn't pick up in the provisioning systems to start to fine-tune that application? And it's something we call an application scope. Suddenly you see your environment in terms of applications and regulatory scopes, and you understand what was intended to actually be running there. Now, once we have this piece, this can be turned into a series of manifests for each of the VMs that are involved in this particular application. Now we move from intended state to being able to detect when applications are being manipulated, attacked. So how does that work? Well, inside this environment, we have, again, those applications and those operating systems, but they're running, of course, on hypervisors. And we've created this protected zone within which we're using the hypervisor to protect, within which we can store those manifests that we talked about. And we can also run these monitoring systems. And these monitoring systems can monitor in real time what's happening inside the virtual machines, the running virtual machines, and compare against those manifests. So if anyone or anything starts to manipulate the operating systems, the processes, how these processes are communicating, and it deviates from the intended state, we know, and we can respond. And that brings us to this last piece, response. Here, we leverage the real power of having a software-defined infrastructure. And we've created something called a remediation broker. And what this does is it houses a library of incident response routines, automated and or orchestrated incident response routines that actually leverage the virtual infrastructure that you already have, including ESX as well as NSX, our network virtualization platform. With ESX, we can automate things like suspending a machine or snapshotting a machine or re-imaging a machine. With something like network virtualization, we could do things like quarantine a machine, block a network connection, insert a third-party service like full packet capture. So suddenly we have a system that in a very simple manner will tell us what actually is supposed to be running on these machines, what their purpose is, can tell us when what's running doesn't match, and then allows us to facilitate this response mechanism. It's about locking down good rather than chasing bad. And that opens up a whole new avenue to shrink the attack surface and to create a security model that's much more aligned to applications than purely just looking at it from an infrastructure level. Now, the way it's used is really in two halves of a problem. The first is when we are dealing with security review and readiness. And here is where the security architects are working with the application teams to get ready for an application that is new or being modified to move into the environment to be able to protect it. And whereas a security and review readiness process may take a couple of months today, suddenly we have something that can be done much faster and much more effectively because both teams can look at a common truth. What are we trying to do with the application there? We can very quickly see and we can very quickly annotate, well, what do we want to have happen if what's running doesn't match what we intend to actually be there and happen? And then secondly, of course, it's about detection and response inside the SOC. Now the Security Operations Center has their window into the software-defined data center. They now have the tools to leverage this really incredible infrastructure, flexible, high-visibility infrastructure to be able to do detection and response in a much more clear, actionable, and orchestrated and automated manner. Now, this isn't simply about what it solves on its own, but going back right to the beginning where we talked about the security controls that we're already using in our environments, it also has the opportunity to make these fundamentally more effective. Now, when you talk about on the compute side and the detect and response side, you're talking about products like endpoint security products, security information and event management, or security analytics products, or MSSPs. And by having these and enabling these to plug in and to leverage AppDefense, they can take advantage of many of the same benefits that we're using. Specifically, the ability to understand the application. Because now these products, when they plug into this environment, are able to see what the intended state in the applications were supposed to be. They can see when what's running doesn't match what was intended on here. And they can leverage that as really rich context for their purpose. Secondly is isolation. Now these products can leverage the ability to protect their kernel drivers, their position on the endpoints. And third is automation. Now, these solutions and services are able to leverage this environment to be able to create automated and orchestrated incident response. This is what VMware AppDefense is. In essence, it's for compute what microsegmentation was for network. And it's going to help the InfoSec team, the security architects, and the Security Operations Center really start to benefit from the power of having a software-defined data center. Thank you so much for joining us today.